Okay, this section is ANOVA, A-N-O-V-A. And what this is short for is AN stands for analysis, O for of, and VA for variance, okay? So this is analysis of variance. That's what ANOVA stands for. We're going to use ANOVA, the test, to test 3 or more means, okay? So the question is there a difference in the means of 3 or more populations? And that's what we're going to test, okay? So ANOVA, even though it's analysis of variance, it's really a test for 3 or more means, okay? So please put that in your notes. I'm just going to put an example up right away because it takes a long time to get through these examples, and so we'll see how it works, okay? So the GPA of students participating in certain college sports programs are compared. At alpha equals 0.10, can one conclude that there was a difference in the mean GPA of the 3 groups, okay? So we have football, basketball, and hockey that we're looking at. Football, basketball, and hockey. Okay, so whoever did this test, they got GPAs of a sample of football players, a sample of basketball players, and a sample of hockey players. So here we go. The football was 3.2, 2.6, 2.4, 2.4, and 1.8. Okay? Hockey people, I'm sorry, basketball people, we had 3.8, 3.1, 2.6, 3.9, and 3.3. And then finally the hockey people, we have 2.6, 1.9, 1.7, 2.5, and 1.9, okay? So again, the original question is that alpha equals 0.10. Is there a difference in the mean GPAs of the 3 groups? Okay, so is there a difference in mean GPAs of the 3 groups? Okay, so that is an analysis of variance question, and it should be obvious because you can have 3 or more groups, and the question will be, is there a difference in the means? Okay, or is there a difference in the averages? Okay, so let's get the problem started. The first step is your HO and H1, as always. And it's really nice because this and the last couple of examples we've done, it's always set, it's standardized, okay? So mu1 equals mu2 equals mu3 will be your HO for an analysis of variance problem. If there was another, if there was like a 10s or something else, however many you have, that's how many mu's you have, okay? And then H1's always going to be at least 1 differs. Okay, so that sets up our HO, H1. Okay, before we get into the critical value, I want to get a few steps done because there's a few steps that we have to get to, and then we can actually run the test, okay? So step 1, what we need to do, I'm going to write step 1 here, is you need to find the mean and standard deviation of each of these samples, okay? So you obviously want to use your calculator or some sort of technology to do that, okay? So you could put all of these into a list in your calculator or in Excel and quickly find the average and standard deviation, okay? So when you're doing your homework or quiz or test, I need you to be able to do that, all right? Since football was given first, I'm going to let that be 1, basketball 2, hockey 3, okay? And so underneath here, I'm going to have an X1 bar, and I'm also going to have an S1, okay? And you need to be able to calculate that. I know all of you guys can do that. I'll probably just give you the numbers in a second, but make sure that you can calculate the mean and standard deviation for each of these samples. Okay? So football comes out to 2.48 for a mean GPA. Basketball is 3.34 for a mean GPA. And hockey is 2.12. Okay, and then the standard deviations Actually, let me just give you the variance, because it's the variance that we really need. So let's square these. Let's give variance. So your variance is 0.252, and your variance is 0.283, and for hockey, your variance is 0.162. Okay, so usually in your calculator it gives you standard deviation, but you can easily square that because we're going to use variance when we get to the steps. Okay? And that's the end of step one. You just need to find the mean and variance for each of the samples. Okay, step two, we have what's called the grand mean, x bar GM, and that stands for grand mean. Okay? And the grand mean, what you do is you pretend that all of these three samples are just one big sample. Okay? And find the mean of that big sample, if we pretended all of that was just one huge sample. So to get the grand mean, you would add all of these values and then divide by the total. So in this case, there's 1, 2, 3, 4, 5 in each group. So you'd add all these numbers and divide by 15. Okay? So sum of them all and divide it by capital N for the total. And I've cheated already for you, and I got that at 2.65. But please make sure you know how to get that. You add up, pretend it's one big sample and add them all up and divide by the total numbers. And that gets you your grand mean. Okay, so that's step one, mean and sample variance for each. Step two is the grand mean. Step three is a formula. And here's what it looks like. It's called the between group variance, SB squared. Between group variance, okay? It's a summation of the n sub I, and then in parentheses you have x bar sub I minus x bar GM, quantity squared, and all of that is divided by k minus 1. Okay, so let's talk about that for just a second here. So in the numerator, we have a summation symbol, which means I'm adding some terms, okay? You have n sub I, so you're going to have however many n's as you have samples, okay? In this case, we have 3 samples, so we're going to have n1, then you're going to come back and have n2, then you're going to come back and have n3, okay? Similarly, with x bar I, you have an x1 bar, and then you're going to come back and have an x2 bar, and then come back and have an x3 bar, okay? X bar GM is always the same, it's 2.65. K, if you remember from before, that's the number of groups. Okay, we looked at, in goodness of fit test, it was the number of categories or the number of groups. In this case, we have 3 groups because there's 3 distinct football, basketball, and hockey. So 3 minus 1 will be 2, and that'll just always be 2 for this problem. Okay? All right, I'm going to erase a little bit just so we can start working on that formula. So let's erase the sample stuff. And we can take a look at this formula in a little bit more detail. Okay, so let's see if we can get this. So SB squared is the summation, so we're going to add stuff. So I'm just going to put a big numerator because we're going to add. The denominator is just k minus 1, which is just 2. Okay, so I'm going to start with each sample. So we have the first sample, which is 5 people were in that sample, times the first mean, which is 2.48, minus the grand mean, which is 2.65 squared. Okay? So just to reiterate what I did, I went to the first group. There were 5 people in the first group. The first sample mean was 2.48, and the grand mean is 2.65. Okay, plus, because we're summing. Then we move over to the next group, the basketball players. There were 5 basketball players. What was the average of the basketball players? It was 3.34 minus the grand mean squared. Okay?
That square symbol's on the outside of the...
It is, on the outside, yes. And then I have one more group to do, plus there were 5 hockey players. their mean GPA was 2.12 minus the grand mean quantity squared. Okay? So when you put all of that together, that gives you what we call SB squared, which is our between group variance. That's what the B stands for, between group variance. Okay? All right, so when you do some number crunching on that, and add that up, and I'll do that with you. And let's see what we get. I would just type it in exactly as I have it on the board with the parentheses. Okay, to 4 decimal places, I'm getting about 1.9648. Okay? So approximately 1.9648 is what everybody should get for their between group variance. And then we're done with that guy, which is step 3. Okay? All right, so you have what's called the between group variance, and then we also have what's called the within group variance, and that'll be step number 4. It's going to be another summation formula that I'll put on the board in just a second. So did everybody get between group at 1.9648 by adding those numbers? Okay, great. So let's erase that. Hold on to that number because we'll use that for our test value. But let's get our within group variance now. Okay, SW squared looks like this. Summation n sub I minus 1, so SW squared. There's 2 summations. There's a summation in the top and a summation in the bottom. So you have n sub I minus 1 in parentheses times s sub I squared. That's your numerator. The denominator is n sub I minus 1. Okay, and we're adding that up. Okay, so what does this mean? Well, you go to each sample, and you're going to look at how many were in that sample, minus 1 times the variance of that sample. Okay, that's why earlier I said, let's go ahead and look at the variance, because here, that's where the variance is going to come in, and so we don't have to square it at this point. Okay? So keep this 1.9648. We'll come back to that guy in just a second. And now let's do the SW squared. So you have 2 things being added. Let's look at the first top. So we have there were 5 minus 1. There were 4 times the variance of the first group, 0.252. Plus 5 minus 1 for the second sample. There were 4, right? 5 minus 1 basketball players times the variance of the basketball players. Then plus 4 times the variance of the hockey players. All of that divided by a sum of n I minus 1. So 5 minus 1 plus 5 minus 1 plus 5 minus 1, which is 4 plus 4 plus 4. Okay? We kind of got lucky in this problem in that they all have the same numbers in each sample. But obviously, if there were 8 in the first sample, then this would be 7, right? If there were 10 basketball players, then this number would be 9, just whatever n minus 1 is. Okay? Okay, let's all calculate this real fast, and that'll give us our SW squared. So we have 4 times 0.252 plus 4 times 0.258 plus 283 plus 4 times 0.162 divided by 12. 0.2323. You guys get about 0.2323? Okay, once you've done the between group variance and the within group variance, so let's just put them over here. What was my SV squared?
1.9648.
And my SW squared? 0.2323?
Yep.
You're ready to go. Okay, those are the two big pieces of information that we need to get through this test now. Okay? So now let's actually do the test. Okay, I have HO and H1 done, right? mu1 equals mu2 equals mu3, great. And what type of test is this? What distribution did I say we're going to use? F distribution. Okay, how does the F distribution work? Does anybody remember? What was weird about it? There was a DFN and a DFD. So if you open up your chart to the F distribution, notice there's a DFN and a DFD. Degrees of freedom for the numerator and degrees of freedom for the denominator. Okay? So when I go to step 2 and I'm looking for the critical values for the F distribution, I need to give you the formula for what's DFN and what's DFD. DFN in this is K minus 1, the number of groups minus 1, okay, so K minus 1, or the number of groups minus 1. And DFD is capital N minus K. Capital N is a sum of all the people, right? In this problem it's people, but it could be anything, but the sum of all the sample values, okay? So there were 5 in each sample, so that's going to be 15, and there were 3 groups, so 15 minus 3, which is 12, okay? So for this particular problem, we had 3 groups minus 1, so my DFN is 2, and we had 15 total people, if you look at all the people in all the groups, minus 3, which is 12. Okay, so everybody make sure you can see where that 2 and that 12 comes from. All right, and then for the F, we're going to use, in this problem, we're going to use, it's a right tail test. So put all the area of 0.10 in the right tail. Okay? All right, so we're looking at our F charts. We're going to go to alpha. .10, and I'm looking for a DFN of 2 and a DFD of 12. Okay. And what is your critical value? 2.81. Yes. Does everybody see that? So something like this, 2.81 is my critical value. So anything above that is going to be a rejection. Okay? So you have DFN, DFD, alpha is 0.10, 2.81 is your critical value for this problem. Okay? Okay, great. Your test value formula, I know we had to do a lot of pre-work to get to it, but it's actually a really easy test value problem once you know what those are. It's just SV squared over SW squared. Okay, isn't that nice? F equals SV squared over SW squared. Of course, it took like 10 minutes to get those, but once you have them, it's pretty easy. So you're going to have 1.96, was that 48? Divided by 2323. And what do you guys get there? About 8.4580. Okay, so we're at 8 something, which is definitely in the rejection region. Okay, great. So step 4, reject HO. If I reject HO, what am I saying?
One's different.
At least one is different. Step 5, at least one differs. Okay, so I I have a little bit of bad news for you. If you reject HO in an ANOVA problem, that means at least one mean is different, okay? So one of the groups has a different average GPA from the other groups, okay? If we reject, we have to do another test to see where that difference lies, okay? So I purposely gave you one that we're obviously rejecting on. We have to do, there's two tests, there's a 2K and a Chef A. We're only going to do the Chef A, okay? So clear your notes and get ready to do the Chef A to see where that difference occurs. Okay, so when we reject HO in ANOVA tests, we're going to move on to the Chef A tests. And here's what your Chef A test looks like. It's not too bad. You just have to do a comparison of each of the groups. So you have FS equals x sub I bar minus x sub j bar. Quantity squared divided by SW squared, parentheses, 1 over n sub I plus 1 over n sub j. Okay? And the critical value is k minus 1 times the critical value for the ANOVA we just did. All right, so let's do the critical value first. So there were 3 groups minus 1, so it's 2 times, and the critical value for the ANOVA test we just did, which was what, 2.81, right? So 2 times 2.81, which is, can we do that in our head? 5.62. So your ANOVA, your Chef A critical value is going to be 5.62. And again, where did this come from? Number of groups minus 1, which is 2, because there are 3 groups. And the critical value we already found for the ANOVA test, right, which was 2.81. So 2 times 2.81 at 5.62, okay? All right, notice I have an x sub I and an x sub j, and that's because we're comparing 2 things, okay? So I have to do each possible combination. So we're going to have to test football versus basketball. We're going to have to test football versus hockey. And we're going to have to test basketball versus hockey. Okay, so to finish this problem, I'm just going to do each of these comparisons with this. If the number comes out at bigger than 5.62, we're going to say, okay, hey, there's a difference between the mean GPAs of those groups, okay? Here, oh, there wasn't a difference between those 2. Oh, there was between these 2, okay? That's kind of how it works. All right, so let's do football versus basketball. So I need football's GPA minus basketball's mean GPA, divided by SW squared, which I still have on the board over there, 1 over how many football players were there, plus 1 over how many basketball players were there. That's how we read this, okay? So it's football players' GPA, mean GPA, minus basketball players' mean GPA, and then square that, okay? So football players' mean GPA, which is what, 248? And what was basketball players' mean GPA?
3.34.
334, great. Quantity squared divided by SW squared, which I still have on the board, 2323, times, well, we're lucky here because there were 5 in every group, so it's 1 over 5 plus 1 over 5. But technically we're doing 5 football players plus 1 over 5 basketball players. So 1/5 plus 1/5. Great. Take that to your calculator. Be super careful because we have this fraction with parentheses. So do the numerator, 2.48 minus 3.34 squared divided by parentheses 0.2323 times 2/5. Okay? And let's see what that comes out to. I'm getting about 7.9595, approximately 7.9595. Okay, our critical value is 5.62, so we're saying, okay, hey, there is a difference between football and basketball. Okay, there is a difference. Because if you remember, with the ANOVA, at least one's different. And now we're trying to figure out exactly where the differences occur. There's a difference between the mean GPAs of football players versus basketball players. Okay? Okay, moving on. Let's go to football and hockey. So you do football GPA minus hockey mean GPA, which was 2.12, quantity squared divided by SW squared, 2323, times, and again, because of this example, all of the sample sizes were the same, so it's always going to be 1/5 plus 1/5. But that's not going to happen with all the problems that you do for ANOVA, right? There could have been 8 basketball players and 6 hockey players, and so these numbers would be different. Okay? All right, let's calculate that one real fast. .2323 times 2/5 on the bottom. I'm getting 13947, so approximately 1.3947. 1.39 is less than 5.62, so there's no difference here in the football versus hockey people. Okay, so no difference. So we have a difference in the mean GPAs of football versus basketball. We don't have a difference between football and hockey. And now the last thing to look at is basketball versus hockey.
So if that number's in the rejection zone, then there is a difference.
There is a difference, yes, correct. Okay? All right, moving to basketball, 334 minus hockey, 212, quantity squared. The SW squared is 2323. And it's, again, 1/5, 1/5, and again, that's only because they all had 5. But technically what's happening here is how many basketball players plus 1 over how many hockey players, okay? And let's calculate that, and we'll finally be done with this problem. Whoa, getting 16.018. So there's definitely a difference there. Did everybody understand what happened in this problem? We did the ANOVA test, which is used to test the difference in the averages of 3 or more groups. What we looked at is the average GPA of basketball versus football versus hockey, okay? It's an F distribution test, so we need to know DFN and DFD, and I gave you how to get that. To get to the test value formula, there's a lot of work to get to this SB squared and SW squared. So do that on the side of your paper first, get those numbers, and then you're ready to do the test, okay? When we went through the test, we found we rejected HO, which said there is a difference in the groups. If you reject HO and find there is a difference, then you go on to do the Chef-A test to find out where the difference occurs. The Chef-A test, the critical value is K minus 1 times the original critical value we just used for ANOVA, and that came out to 5.62. Then you have to do each comparison, football versus basketball, football versus hockey, basketball versus hockey. Number crunch there, if this number comes out bigger than that number, then there is a difference between those groups, okay? There's definitely going to be one of these problems on your next test, definitely. Any questions?